start with the steering system. The rudder is cut from a board of high-density polyethylene, and I use nailing plates to give it some rigidity, because otherwise it flexes way too much. The rudder is attached to the kayak with this piece of wood, and it swivels about 90 degrees. I have this bolt right here, and it butts against the wood when it's fully down in the water. It stops it from going any further. Moving on from the main rudder, we have the mounting bracket. That is just a PVC pipe that has been cut in half, flattened, and then bent into this bracket shape. There's just a single bolt that connects the rudder to the bracket, and there are washers in between the wood and the PVC to stop squeaking. Now the bracket itself is connected to the kayak with 4 construction screws, and since these screws have a shank on them, I had to have this piece of wood right here just so the shank wouldn't be inside the kayak. You can see that the screws are just poking through there. Basically, in the old system, the tiller could only turn to right here, and that's not very much of a turning radius. So I added this PVC pipe, and that greatly increases the turning range. Now normally the end of this pipe is right here when this tiller is down, or when the whole rudder setup is down. So this tiller rope runs all the way up here along the splash guard of the kayak, and it goes all the way up here to this pulley. When the kayak is in the water and the rudder is down, this rope has a lot more slack in it, and I can pull it all the way up to this pulley. This here is my leeboard. When you're sailing, you rotate it. You just let down this piece of PVC pipe, and when it's fully straight down in the water, it rests against this cup holder in the seat of my kayak, and I can just cross my legs over it to keep it in position. This piece comes off. I just have a pin that keeps it from falling off. Basically, this is 2 pieces of high-density polyethylene that has been riveted with nailing plates, and I have a piece of PVC running down the center to give it structure. The keel mechanism is held in place with 2 U-bolts on each side of the kayak. So the mast is 1 1/4 inch Schedule 40 PVC. I have a piece of 1 inch PVC running on the inside of the mast to give it a bit of extra rigidity, and that extra piece of PVC is just screwed in with the cleat. This is a lateen rig. Basically, you just have a equilateral triangle that's cut out of a piece of tarp. The sail was actually 8 feet originally. I cut it down to 5 feet because an 8-foot sail was just too much for that kayak. I constantly was capsizing while testing it. That gives you about 12 square feet of sail, as compared to 27 square feet that you would get with an 8-foot sail. So the spars, they are 1 inch PVC, Schedule 40, and they are held together by 2 eye bolts that have been bent into each other with the help of a bench vise. You have tarp clips that are attached with zip ties. I have threaded rod running through the PVC, and the zip ties are just wrapped around that. I also have an eye bolt running through the end of the spar, the bottom spar. Another eye bolt 1/3 of the way down the spar. This rope, it allows you to control the angle of the sail. So for a gooseneck, I just have a piece of rope that allows the sail to slide up and down the mast. Up at the top of the mast, I have a another eye bolt that allows me to lift the sail up. That rope runs all the way down to the bottom of the mast, rope tied off. And the nice thing about having the cleat attached to the mast is you can just lift the entire sail up. So the mast is inserted through this hole that I cut with a hole saw, and it gets inserted into this T-fitting. I have the T-fitting held in place with 2 bolts.